Okay, we're back. So this is another friction problem. We have a 10 kilogram box is being pulled by a force of 40 newtons to the right. The coefficient of static friction is 0.65. The velocity of the box is 0. What is the friction force on the box? So let's do free body diagram. We draw a line. There's the box. And we say to ourselves, all right, here is our applied force of 40 newtons. And then we say to ourselves, what's touching it plus gravity? Well, we've got the ground is touching it, which creates a normal force. We've also got a friction force, which is acting opposite to the direction of intended motion. And we've got gravity going down. So friction and gravity, normal force, and applied force. Now, the question is asking, what is the friction force? That's what we're trying to figure out. So we're trying to find out what that guy is. So let's go ahead and do summation of the forces is equal to F net. Now if we do that, we have to specify a positive direction. And then we say, all right, well, friction force is obviously going negative. Applied force is positive. And that's all equal to F net. But F net is equal to MA. But wait a second. It says that the velocity is 0. Well, and it doesn't say that it's accelerating. And the box is just standing there with a constant velocity of 0, which means it's not moving. Now, if you think about this for a second, it should be clear that therefore the acceleration is 0. But why wouldn't the box move with a 40 Newton force? Well, if I draw the graph here for friction, kind of looks like this. This part's static, and this is kinetic, and this is force of friction, and this is applied force. Then this point right there, the maximum friction possible, is in fact from the equation force of friction equals mu s Fn, and that's equal to mu s mg. And of course we realize that if we substitute our values in for that, 0.65 times 10 kilograms times 9.8 newtons per kilogram, we'll get approximately 65 newtons. That means this box is not going to budge without at least approximately 65 newtons of force. So that means 40 newtons of force is not enough to move it. So what's the acceleration? It's 0. So now this problem becomes extremely simple. That just means that the applied force is equal to the friction force, and since the applied force was 40 newtons, that's also what the friction force is. And so this is simply a concept question hiding as a calculation question. Answer: 40 newtons of force is how much the friction has to be if the box is not moving. Well, hope you guys enjoyed that problem. We'll see you next time.